I'm making a video game with underwater mechanics. In this devlog, gathering feedback, fixing issues, exploration feature, custom music. Thank you so much to those that tried my game and responded to the survey, sent Discord messages, responded on Reddit, or played on Twitch and offered their suggestions. The game will be much better thanks to all your input. The first order of business was gathering all the feedback into a document and categorizing it, then creating actionable items from that list. From the list, here are the categories that each bug or suggestion fell into: player movement and controls, frustrating mechanics, feature suggestions. Oddities with the controls was one of the more recurring pieces of feedback offered, particularly the usage of shift for both going fast and slowing down, which makes the game feel like a constant fight between holding and releasing shift. I changed the default syncing speed to be slower and clamped. Pressing shift now acts like the rest of the movement and makes things go faster. The chest still affects your syncing speed. This change will also allow me to have traps and enemies that require you to sync faster to avoid them. This also makes some of the areas where you have to avoid hitting both the ceiling and the floor easier, since you don't have to constantly mash spacebar to avoid the floor. A few of the feedback comments touched on the unnatural feeling of the movement for the player. What currently happens when you press shift is the player goes from walk velocity to run velocity without a gradual transition. The same thing happens when swimming. I plan to address this in the future by using forces and impulses in an attempt to make the velocity change gradually. A friend of mine gave me a quick crash course on how to use blend trees. When I rework the movement, I'll also integrate a blend tree to make the shift actions make the animations apply faster. As part of that, I'll include animation events that add a force to the player, so the movement looks more natural. A force pushes you up as the arms move down. The first frustrating mechanic I tackled was the awkwardness of picking up the chest. Prior to the change, if you dropped a chest in a trap, you had to stand next to it and take damage again before you could pick it up. Players requested the ability to be able to grab the chest while standing on it. This change was easy to make. I just had to increase the grab range and shift the circle down a bit. I still want the player to be looking at the chest when grabbing it, so they can't currently pick up items behind them. A few things were pointed out in regards to the current damage model. 1. The damage only applies once, so if you stay in the same spot, the spikes don't hurt you again. 2. The damage does not feel punishing. You get hit once, but it doesn't really make you not want to get hit again. Combined with damage applying consistently, a suggestion to implement invulnerability was provided. I think this makes sense in conjunction, and most platformers have this mechanic, so I decided to add it into the game. I added an invincibility period after taking damage and made the player toggle between colors to give more indication that you were hit. Perhaps I will toy around with the alpha value so you're slightly transparent while damaged. For now, invincibility lasts about 1 second, but that can be changed based on how it feels. With invincibility in, I worked on changing the damage for the traps to consistently do damage. I didn't use a timer or worry about how many times damage was applied, since you won't get hurt while invincible. I did change the traps to track when the player is within its bounds so it can consistently try to do damage while you're within its collider box. In terms of collisions, another frustration was that there seems to be ghost collisions when you're swimming. I'm currently using a rectangular collider, so I played around with shrinking that a bit. However, the collider causes the player to sink a bit lower when walking, and it still does not solve the problem of the player having the legs up when swimming. I plan to update this in the future and play around with shrinking the collider while you're in the swim motion, just so the legs are the collider bounds. The expansiveness of the maps also brought some problems, since it is hard to tell where you are when you haven't played the map 1,000 times like I have. The level currently has color variations in the water to mark out zones. In a live playtest I was able to watch on Twitch, the player didn't make the connection to use the watercolor differences as a way to navigate. So, I thought of a couple ideas to let the player know where they are and where the anchor is. The first idea was to add a mechanic that would give you an arrow pointing to where the anchor is. This wasn't implemented since knowing where the anchor is doesn't tell you how to get there, especially if the arrow points through walls. My second idea was to use an A-star path library and display a particle path towards the anchor. This way you know which way to go. I also discarded this since you may want to navigate back to a particular zone if you left a chest behind, so just knowing how to get to the anchor may not be as useful. The idea I went with was to add an exploration system that would clear the map as you explored areas. Now, this is the part of game development where we find why it's development and not construction, because this took a lot of effort and iteration to figure out. At first, I was going to use trigger colliders to reveal areas of the map. After watching some tutorials on minimaps, I realized I could use a render texture to display a full view of the map. So then all I had to do was just work on hiding the map view, but keeping the player view clear. I used the grid information class to track if a tile was visited, and originally tinkered with just setting the color of the tile. I then increased the range of exploration tiles just to visualize it. I added the render texture as a canvas raw image and had it on the corner while I tested just to visualize what I wanted the map to show eventually. With this info now tracking correctly, I proceeded to do some research into shaders. The original idea was to write a shader that would darken out areas you hadn't seen. I played around with the shader graph and created a shader that would just tint the render texture as the first part to get things working. Things all looked fine in the scene view, but when I tried it in game, I ran into a Unity bug. I even tried using a quad just to make sure it definitely was the shaders not working. I tried multiple ways of using the shader as a post-processing effect on the camera so the shader wasn't applied to the render texture on the canvas, but that didn't work. I then looked into recreating the map by copying the pixel colors from the original texture and swapping out pixels to black if they were not explored. I started by making a simple heat map of what had been visited. The idea being I just needed to multiply color values to get the final product. However, if you look at the heat map here compared to the camera vision, the positions on the map would need to be translated from camera space to world space to minimap space in order to draw the right colors, which seemed like a lot of math at the time, so I discarded that idea. I asked a friend for suggestions and he mentioned that it was like a fog of war and sent me a link to a couple of assets. I browsed through the fog asset and the review seemed good, but I wasn't sure about its 2D capabilities. So I emailed the maintainer asking them if their asset would support my use case. Fog of war on the render camera, but not the main camera. The developer gave me a suggestion to try with their asset, which relied on changing the culling layers of the cameras. I tried an experiment in their example scenes and it all seemed to work great. So I worked on adding the asset to the interaction zoo first. I played with the 2D settings and set up a special component that would ensure the fog of war had the right layer and sorting layer, since those are critical for the feature to work. I also created a few effectors so the fog would clear the full screen worth of range on the large map. Once I had that working, I switched the UI around so you could open up the minimap with a key. Then, I proceeded to add the fog of war to the tutorial and test it out. Since that worked great, I then added it to the first level. The first level is about 3 times the size in width and 4 in length. As soon as I generate the fog of war objects, the editor became very laggy, but I was hoping it was just an editor problem. Trying in-game proved that was not the case. The hitching you see is not the recording pausing, but the actual engine struggling. In fact, you can measure the game in seconds per frame while this feature is running. Fortunately, the Foggia asset had a mode for a map instead of a grid, so I tried switching to that. This was more performant, but I had to increase the range of sight drastically. While looking at the scene, I realized there's less fog tiles that are much larger, so using the fog system in this mode gave me a setup where you touch the corner and it reveals huge parts of the map, which I didn't like, so it was back to the drawing board. I looked at some tutorials for inspiration and found these from CodeMonkey. As I was getting started with implementing my own grid and mesh, I had the idea to use the existing tile map setup and just add a single color tile set on the right sorting layer. This should work already with the render texture and minimap setup, and I already knew how to change tiles since I did that when exploring the shader idea. Tweaking it a bit, I ended up using the setTile method with a null value. This worked quite nicely in the interaction zoo, so learning from my mistake, it was time to apply it to the first level. This performed better than the Fox system, but still wasn't smooth. The bad performance was because refresh all tiles is called after every exploration step. I changed the logic to only compute a set of positions visited. At the end, in a fixed update, all the tiles are updated. Since the tile map doesn't need to be refreshed until the player opens the minimap to see the exploration progress, I put the refresh all tiles call on a function that's only called when you open the minimap. With the feature now working, it was time to make the pause menu still work while the map is up. I then added it back to the tutorial level just to have the feature everywhere. The tutorial will need to get redone, but that's a problem for later. The music for the first demo all came from this free Unity asset. Since making music seemed like it was going to add even more learning, I decided to try to get some music commissioned. I found a musician through Twitter who was willing to work with me. Working with Victor was really nice. They had a prompt to fill out where I could send inspiration. Since I've been listening to an underwater piano playlist, I really wanted to have some piano music for the game. Victor composed a set of loops for me that would fit the first level and also created a 4-minute long loop that I could use for the full level music. For now, I'll have this on repeat since it takes about 6 minutes to finish the level if you don't boost at all. Here's the snippet of the music for the first level. Last devlog, I mentioned I was going to start sketching out and concepting the next level. This didn't happen at all since I received more feedback than expected and the exploration feature took so long. That's it for this devlog. My focus for the next part will be rework the movement so it feels less robotic, try to fix the collider when swimming, start designing the second level. Until next time.